Everybody hear me?
Yes, sir. Yes, sir.
All right. We want to talk about writing PLC programs, and then after, so, but we have to arrange sometime between next week and the other week for an in-house session where we have to go up to UTech to go do whatever it is that we're doing. Okay, so I don't know. Well, I've sent a message in the group, but it's going to be next week or the other week at the end of this class. Because I'm not sure with this format how far we'll reach. So let's see how it works. But it's either next week or the other week we're going to have one or two in-person sessions, and then we'll go back to original. All right, so your programmable logic controller is a device that is used to, as it says, control equipment, and it's going to be used to sequence what happens in a process. So let me, because I have limited space, let me just describe a process, and then we talk about a simple process, and we describe what we are about here. So it has an inlet, it has an outlet. So it's going to let in the fluid. When it reach the level of the limit switch, which we indicate here, then it's going to turn on the stir for 10 seconds. So so when you push the start button, inlet opens. Oh. So we say that fluid is going to flow. You're going to press the start button. Inlet opens. We're going to fill up until you reach the limit switch. So let me make this a little more accurate.
Yeah, sorry, I record, sir.
I don't hear you.
Just
no.
if you're recording.
So you're going to record it? All right, let me record it.
Record, yeah, yes, sir. Thanks.
All right. So we say that just writing brief notes here. You press the start button, and the inlet open fluid flows until the limit switch is triggered. The stirrer is on, turns on. Let's say 10 seconds. And then after that, the outlet opens. So we want to have a situation like this, and then we want to automate the process. So we are going to talk about how we write the program for this, and then what we are going to do is the additional programming features that we want, if we want it to turn on for 10, 15, we want it to go over a number of times and all those type of things. All right, so we are going to be just discussing how you write a program for the PLC to put it to start to automate the process. I should point out that the program that we are using is CX Programmer. You have 1,000 million different types of PLC, and there are some differences in the program, but once you learn how to program one, then you basically have the idea of how to program the rest of them. There are some basic differences, yes, but not anything major. I should also explain, just for the purpose of discussion, why is it that we use CX Programmer and not the rest of them? Well, the initial reason for using Omron. It's Omron that uses the CX programmer. The initial reason for us using Omron is that we are a teaching facility. We're not business oriented, meaning that you are running a process as a business. So let me backtrack a little bit. Explaining the choice that we make is to explain to you that when you're considering what PLC you are going to buy for whatever purposes you're going to run, these are some of the things that you will need to consider. All right. So what I was saying is that UTech, we here at UTech, we are teaching university. So one of the things that influence us in the choice of Omron is that when you buy Omron, you can get support in Jamaica, and you have somebody that you can call for support overseas. Meaning when I say support, because people are doing many different projects. It's not a dedicated system. Say you're making concrete block and you have a program. So the program that you're going to program is to run a concrete, to control that process of making a concrete block or making juice or whatever it is, that one dedicated process. Many projects, people doing different things with the PLC. So we have a whole heap of questions that we need to ask, and we don't have any answers for it, and we need to get answers for it. So if we went with the other popular brands like General Electric, that is Allen Bradley, or the Mitsubishi, or any other, all of the other brands have very little support in Jamaica. You can't ask somebody no question out here, and there's nobody that you can ask overseas. All right. So in other words, since we want to be able to ask questions and get answers as to how you do this and how you do that and how you do that, that was one thing that influenced our choice. The second thing that influenced our choice is that at the time it was cheaper than the rest. It's no longer so, but that is the case. Now, if like Bauxite Company, is which one of them they use? Name of the PLC escapes me right here. It's not Allen Bradley. It's, I don't remember the name right off the bottom of my head. But let me explain like that now. If the Bauxite Company, the brand that they use, first of all, the PLC that they said is for 10 years ago, it was the cheapest one they gave you was $1 million. And then you had to take another $1 million to go there and trade. Go to the company and trade in Arizona, and then come back to run whatever it is that you are going to run. All right. So the point about it is that that choice was made because the PLC was offering, the PLC that they were using, they were offering features that they needed to run the Bauxite plant. We couldn't use it at UTech because, well, let me not tell that. We attempted to use it at UTech, paid $1 million and got one PLC. So one PLC, and then we send somebody to trade, not $1 million, and they come back and say they never understand nothing. $2 million and so I'm saying all of that just to say that your choice for whatever equipment that you're buying must be determined by what it is that you are doing. All right, must be determined by what process that you are doing and what kind of process you're running. Like we say, we're an educational institution. So when those of us who we went with Omron, because the powers that be went with, well, I can't remember the name. There's a popular brand, but old age. It will happen to someone. So now. So back to what we were talking about. This process, we're going to be talking about using CX programmer, but you will be able to understand other processes. And the reason why we are using CX programmer, like I said, is because it's cost effective and you have support. Allen Bradley, you have to take a course of 5,000 US to get the knowledge that you need to deal with their PLC. This one you go Canada or US and pay mostly like, I don't remember how much you pay at the time, and you can get the training that you need to use the PLC. All right. So first thing, be careful of which brand that you are going to use. All right. Not all of them offer the kind of support that you need. All right. So back to the lesson at hand. So we want to say what is it that we do when we have a process and we say we need to automate the process. So we have, again, press the start button, inlet open, liquid fill up, limit switch trigger, turn on the stir for 10 seconds, and then let it up. All right, so the first thing that you have to do is list your inputs and your outputs. I have limited space on the board. The correct device failed this morning. So I've used my phone. All right, so if you look at the process, we say that your input is anything that you actuate, your output is anything that is going to be actuated. So any valve or anything like that, and so forth, is your output. Anything that is a switch or a sensor is your input. So if you look at this diagram here, can you tell me what you think are the inputs?
Sir, start and stop, sir.
Start and stop. Limit switch. Yeah, we'll put it down here. All right. So, what are your outputs?
Stir,
Stir.
the fluid, well, fluid flow, man.
All right. So you call it the
Inlet,
inlet valve and your outlet valve. All right. So the inputs are your start switch, your stop switch, your limit switch, and your outputs are your stir, your inlet valve, and your outlet valve. Now, so that is the next thing that we make it switching to talk about common sense and those kind of things. Now, you have PLCs that have a minimum of 4 inputs and 3 outputs. And you have PLC that have hundreds of inputs and hundreds of outputs. Of course, the cost will vary depending on the amount of inputs and outputs that you have. The ones that we use in the lab have 20 inputs and about the same amount of outputs, or 14 outputs or so. And that PLC, last time we checked the cost, although the dollar is changing, is about $40,000. Right? The one that I said with 4 inputs and 3 outputs is $25,000 in all for a package. The one with the whole heap of outputs and inputs, the 100 outputs and inputs, is millions of dollars. So one of the reasons when you take a process and list the inputs and outputs is that you can say which PLC you're going to buy to control the process, so that you don't go and buy, which is and people personally say, oh no man, we're not going to do that. You're not going to buy $1 million PLC when you only need a $25,000 PLC because you got name brand. Well, I have the example that UTech went and did. UTech buy the $2 million thing because they didn't need to teach PLC. And somebody just said, oh, all right, we're going to buy a PLC. We're going to buy a PLC. How much it costs? Type in name brand. Oh, $1 million them sell it for. $1 million I have to buy. You go to the management and say, we need $2 million to buy a PLC because we're doing PLC training. When you come, you can use it 1 and 2 is only 1, and you have a class of 25 students. So what I'm saying is not far-fetched, because sometimes part of engineering is making proper decisions based on what is in front of you. What is in front of us here is 3 input and 3 output. So in this particular case, a $25,000 PLC can suffice rather than go buy. Why I can't remember the name of the PLC where Jamal Kwan and all them people use. Honeywell. Yeah, you don't go buy a Honeywell PLC to go do one little process like what I described here. Alright? So as engineers, we have to be cognizant of those kind of decisions. Right? And like I said, don't tell me say, yeah, we wouldn't do it because I have one glaring example. Alright? And I have more examples that we can talk about, but we're using that one glaring example because it's pointing at us. Alright, so that's the first thing. You have to listen inputs, listen outputs. And just that alone will tell you what is the size of the PLC that you need to buy. Now, granted, what I describe here is a simple little process that is just meant for the discussion of our class. You are going to have a process, and then you're going to be thinking in a few years, maybe we're going to expand and all those type of things, so that will also feature in your decision making. But decision making is very important when we decide what we're going to do. And I don't think, as Jamaicans, we think very often. We just do. Then if it's slavery, make we just decide say we must just follow orders all the time. All right. Anyway, back from the politics and back to the thing. So having decided on your inputs and your outputs, the next thing that you have to do is label, assign an address. What is called an address for your input and your output. I'm hoping that this is making sense to you, because it isn't about that through your PLC as this side of the input and this side of the PLC is the output. But one side of the PLC is input, one side of the PLC is output. And each of the inputs that we have, we're going to put an address to it. So now, how will we do an address? An address in Omron has 3 zeros. The 3 zeros indicate to the machine, the program, that 000 represents an input. So just to go aside, in Alan Bradley, the PLC, I represents input. So you have an I, but in CX programmer, in Omron, 000 indicates to the processor that is an input. Now, each of these has to be assigned, the start, the stop, and limit switch has to be assigned a unique address. All right, so we have 0, 0 as one address. Stop is 000, we're going to put 0, 1. And the limit switch, we're going to put 0, 0, 0 to indicate the input, and 0, 2. So the 0, 0, 0 is an input, and each of these, the 0, 0 now is an identifier. So 0, 0 is the stop, the start, 0, 1 is the stop, and 0, 2 is the limit switch. So when we come to wiring up the PLC, we know exactly where on the PLC we wire the limit switch to. There's a 0, 2 on the input side. You're going to connect the wire, connected the limit switch to 0, 2 on the input side. And same thing for start, 0, 0 and 0, 1. And this is also very important. And I sorry to put it in so many stories of the real practical things about why is it that we have to label and these things. A couple years ago, some fellows from UTech, they contacted me from cement company and said that, oh, I want some people from UTech to come and rewire our PLC. The wire them start to get flaky, and we need some people, we need some students to come and rewire the system. Leave out the part that when the students arrive at cement company, the man them who out there, I said, how them future. You know, nobody come for your work, you know. So they have to explain, say, no, we can't manage this because you don't know about no PLC. Them you don't know about PLC. So we have to give them the work. We can't give you the work because most them tell me so they nearly get beat and have to run every place. But so here the problem that cement company have. They don't have anything that says the start switch wire to 0, 0, the stop switch wire to 0, 1, the limit switch wire to 0, 2, and all the equipment is all over the place. So what should I take them 2 days to do? Take them 2 weeks. Because I have to walk all over the place to find out and trace wires back to the control panel for the PLC. If they had labeled the thing, then they wouldn't spend so much money. Wouldn't have to give them 2 weeks pay instead of 2 days pay, 2 day work for a 2 day work. All right. So documenting the thing is very important. All right. So we say 0, 0, 0 indicates to the processor that is an input, and 0, 0. What are the is the address for the input. All right. Output. The output, we put 0, 1, 0. So that indicates that is an output. And again, each individual slot, so we're going to connect the stirrer. This is arbitrary. Can connect the stirrer to 0, 0. 0, 1, 0, 0, 1 is the inlet valve, and 0, 1, 0, that 0, 2 is the outlet valve. So the first part, the 0, 1, 0, indicates that it is a output. And the 0, 0, 0 indicates that is an input. Is it the tell that this have to be a Pentecostal church? I attend a nice United church where when the pastor preach, everybody just sits quietly and listen. So this have to be a Pentecostal church. I don't know what if in a Pentecostal church I hear not that this is a foolishness attack.
Everything.
Okay. So we need to know if we're making any sense or if we need to do this or need to do that. Blah, blah.
Yeah, good so far, sir. Everything good so far.
All right. If you can take in more than zeros, what do you mean?
I just label my
Yeah. This does not do it binary. This just 000. It's just an address.
So it's like say
When
plus 9 at 12.
here what happened now? I didn't want to mention it before.
9
What?
plus you say 20.
But here what happened?
Agree, say
You see,
1.
you have different
Say work. Let me say,
Yeah.
buy a car.
cards that you can put on.
Hold on, who they talk and mute their mic? I can't hear, sir.
I'm gonna say to myself, say, you know what?
Somebody attack, mute your mic.
Good. All right. You hear me now?
Yes, sir.
All right. So the 000 and the 010 don't do it binary. No. Well, from our perspective, we're not to do it binary. Maybe from machine level 000 have something to do with binary, but it's just indicated their input. What you're going to realize if when you show you the PLC,
Sir,
the PLC I show you.
sir,
Yes.
him attack after the full stop, we have 01 and then 02.
Yeah. So the 010 indicate as is an address for the to say that is output, and then 02 if let's just say that this is the top of the PLC. You just that's the part we don't like. Yeah, you're going to see when you look at the PLC, you're going to see slots 01, 02, 03, 04, and so forth.
Oh, so it is registered to each slot.
Yeah, so you just going yeah. So you're going to connect to, let's say this is the input side. You're going to connect your stop switch there. And on the output side, you're going to see some numbers again 01, 02, up to I think 11. So each of those slots, if you decide to name this, let me not put a 00 here, but 00 is on it. So 000 and 02 go. But let's say you will give the inlet valve the address 010. It is expected that you are going to connect to the output side, and the inlet valve must be connected here. So the wire must connect to the PLC at 01. All right. So you have to.
Yes, sir, we get here now.
So you don't have nothing to do with binary. All right. Let me just put a little note here, so because I've heard about all of this. So just bear in mind what the process setup is like. All right. So now, let me talk about some programming constructs. The PLC uses icons. It doesn't use, it's like our C program and all other programs use, no, we use symbols. So here are some symbols. This is a normally open switch. That's a symbol for a normally open switch. And a normally open switch is just that, it's normally open. When you press it, so all of the lights in your house, like this light here, is normally open. So it's not off, and when we press it, it's going to turn on. Go ahead a little bit. You see just as well without it. All right, so that's normally open. The other symbol that you will see that we are going to talk about is one that says that's a normally closed switch. Now, a normally closed switch, it has a line through it. Normally closed switch means exactly that. Normally it is closed, so the thing is running, and when you trigger it, it opens. So it is on normally, and then when you press it, it turns off. Similarly, we have that little circle, which means output. And then tell you says a normally open output. Means that when you press this switch, it turns on. And then you will see, which we hardly use. So this is normally open. And this is a normally closed output. Alright, so you will see those are the symbols that are used in the program. Now, the other symbol that is used in the program, we are going to talk about because we are going to need, if you remember the described process, we need a timer. So there are timers to time the process. And there are other, so if you want to add, want to subtract, we want to count, we have special functions for those. But the basic program that we're going to use, it involves normally closed switches, normally open switches, normally open outputs, normally closed outputs. All right, so having said that, let me go to some programming constructs. I hope somebody write down these because we're going to need, I can just go back. Programming construct number 1. Before I go to the PLC program itself. Programming construct number 1. If you see a program, this line of code, it means something. So let us say that this is 0, 1, 0. And we say that is a motor. And this is 0, 0, 0, 0, 1. So it's start switch. When the program uses what is called ladder logic. When you write each of these, this thing is called a run. So each line of code that you write, or each programming line that you write, is called a run. So now this particular line of code, I'm going to take the switch and connect it to an output. What that says is that when I trigger the start switch, in the program, when I trigger the start switch, it's going to close and it's going to turn on the motor. So this thing here is going to close and turn on the motor when it's triggered. So this line means that the start switch is connected to the motor, and when the start switch is triggered, it's going to turn on the motor. All right, next programming construct. I'm going to rub off up here. This is called an AND. So let's say that this is 0 and 0. This is our motor. And this is 0, 0, 0, that's 0, 0. Arbitrary. So let's say it's limit switch. And let's say this is 0, 0, 0, that's 0, 1. So let's say this is theta coil. The AND construct now is saying, all right, somebody explain what that is saying to me, if you understand. Let me see if the church understand what this is. What this bit
So what are the second part? You can't say what kind of coil. What I see word?
theta.
So in order for the motor activate, the limit switch and the heater of the get. So or the temperature of reach.
All right. The heater and the limit switch have to turn on before the motor can turn
Before the
on.
motor, yes.
Yeah.
Amen, brother. All right. So tell me what this one means.
Sir, that one that too easy. R.
That is R. All right. So this one here now say the heater or the limit switch. The heater or the limit switch can turn on the motor. All right. So if you see that line in the program, either this or this will turn on the motor. All right. So now let me deal with the most important programming construct that we can have. And let me just tell you the name of the. This is called a latch. So this is 000.00. This is 000.01. This is 010.00. That's the motor. And here, all right, so this programming construct is called a latch. So you would have remembered the word latch when you were doing digital. Or not, it don't matter. We're giving you an opportunity to gain a politics. All right, so now, here's what this, normally, you have a start switch here, and a stop switch here. Anything you want to start, so this is the motor. Anything you want to start, you press this. Anything you want to stop, you press this. Now you notice that the R connection has the same address as the motor. So what is this for? This whole latch thing, first of all, the program allows for, any PLC program allows for an output to be regarded as an input. Meaning that you can use the fact that, all right, I turn on the motor and use the fact that the motor is on. Because now the program stores a bit in the memory of the processor. So it does the motor turn on, so the bit goes high. And you can use that fact that the bit goes high to turn on something else. So when the motor turn on, then you can use it to turn on the fan. So it allows an output to be used as a switch, as an input switch. So you notice here, so this motor and this input switch has the same address. So anything happen to this, happen to this. Anything happen to the motor, happen to this input switch, because they have the same address. So here's what the thing is now. So if I close the start switch, and it's a push button switch, then when I close the switch, then we think of current as flowing from left to right. So current can reach the motor. So the motor is going to turn on. But let us say, so the motor turn on. Let me write on here. You close the switch, the motor turn on. When the motor turn on, this switch is going to turn on. Now, if, so this was on, I push this switch, it turn on. This is now going to turn on. If I take my finger off the push button switch, it is a push button switch, not a regular standard switch. When I take my finger off of this, it's going to turn off. But guess what? Because this is on, this bit is turned on, then it continues. The motor will still continue. So I don't have to keep this, I don't have to buy a single pole switch. I can buy a push button switch. Push button switch, turn it on, and because it's latched, it will stay on. And if I want it to stop,
You push back the button.
you push back this button, the stop one. So the stop one is going to break the circuit. So no current can reach the motor turns off, and anything that happens to this switch bit, then this bit turns off as well. So everything going to turn off. So this switch start it and this switch stop it. So this is the programming construct that we use for all our PLC construct. And here's why we use this instead of, we use a latch. If there's no latch, so this program, let us say that this is how we wrote the code. Because we have single pole, single throw switch. So when we turn on, just like your house, you switch on the light, you expect that it's going to stay on. So it stay on, motor run, why we have to put on a latch for the code for. That doesn't make no sense. So Mr. Fraser tell me foolishness. Mr. Fraser, the manager, I said, write the code, run the thing, and single pole switch them up. All right, write it on. This is what I use. This start it and this stop it. So a few years later, somebody said, boy, this switch not working, or somebody buy some new switch. And the person said, well, I'll buy some push button switch. This single pole, single throw thing not going to work. Put the push button switch. Everything shut down. I'm not working, and nobody don't know why. Whenever you write in the code, it has to be something that no matter, it's supposed to be hardware independent. No matter what the hardware that you use in there, it's supposed to work no matter what. So, strong suggestion. Whenever we're writing our construct, we use a latch. So that let me segue to something else. Like I said, maybe I'm going off on too many stories. But one of the stories is not bad, it's two. It was down Mobile, Water Commission, Bow Plant, and they did ask us to, I remember what they did ask us to spend 2 days in the cheap hotel down in Mobile. Teach the people in the Water Commission. I don't remember what we were supposed to teach them. And then they find out we know about PLC. And they say, oh, know about PLC, they can teach you some things. Those are the engineers that were down there. So we say then, so nobody never trained you. I said, no. What happened is that the person who come to train him come. So we say, oh, okay, he come from France. So he never leave a manual or something, because what we learn, most of what we learn is just whenever we see a problem, we just go to the manual. Them said, no, the problem is that the manual is in French. French? Yes, them leave the manual, now the manual is in French. So we say, so what happens when you have a problem? Well, we have to call, where is the man? He's in France. So we say, oh. And they say, yeah, I'm taking British Airways from France, and then I'm taking British Airways from Jamaica. They have to book him in, not the hotel that we were in, because the hotel that we were in, well, let me not go there about what the smell of the hotel suggests, or the room where we didn't suggest. But him put him up in a nice hotel for a week. Him come, him change one line of the program, and spend the next 6 days and drink Great Stripe and look every young girl that he can see between Bobby and Portuguese. True story, not no lie. Taking British Airways, go back to France, and wait until them call him again. So, all of that is foolishness. total and complete foolishness. But so we love waste money. So it is important to understand the code. I understand that some people will write the code so that you have to call them back every minute because don't be that person. That they have to call them back every minute unless it's in a first world country. So draw this thing at the right place. So this is the programming construct that we are going to use. All right, so now we have our input and output, and we have our programming construct. So now we want to write the program. When we say the program that we want to write is when the start switch is pushed, inlet valve turn on, it turn on till we limit switches turn triggered, and then it let out the water out of the outlet valve. So we want to write that code now. So remember this. I don't have enough board space. So let me say that, write one thing before. If we're writing a code, we have to write what is called a statement list. It's really an algorithm. Black people don't like algorithms. Black people like to look for the computer and program. And if let me what's biblical here, the Bible says if you are take out the things out of the strong man, you have to take out the strong man first. In other words, you have to have a plan. So make we have a plan. The statement list is your plan of action. So your statement list is going to break down the thing in words before you code. So let me tell you what the statement list looks like. You're going to number each line. So first thing, you're going to put starts when. You say, what is the process that is started? And you're going to say, it ends when. So now this thing that we have all right. So this process that we have, when does it start? Pentecostal church. All right, so what do you do? Add the water to the thing.
Oh, my.
So it starts when the start is pushed.
Yeah.
All right, let me just put that out. What is started? Need right back.
Now the valve water and fluid.
So which one of these actuators is started? There's three actuators we have. So when we press the start button, which one of these three? The stir or the inlet, the stir or the outlet is?
The inlet.
The inlet is activated. And when does that inlet turn off?
When the limit switch Get them, send a message, say reach a level.
When the limit switch is activated. All right, now the second line in our code starts when the first one ends. So it starts when limit switch so that is how we ensure that the process moves from one to the next. So the limit switch is activated. What is turned on when the limit switch triggers? When we reach the level limit, which one of these three is turned on? Church? The stir. And it ends. We said that the stir is going to turn on for 10 seconds. So we're going to put ends after 10 seconds. What's the third thing? Well, so it starts when 10 seconds. And we're going to use a timer. And you say the outlet valve activated. And we didn't put the thing, it opened the outlet valve. Should we have a time when the outlet valve, after you open the outlet valve, you close it up? I'm asking, should we? Huh? Yeah. So all right, and so after let's say 10 seconds. So this is our statement list. So a statement list lists every step in the process from one to the next to the next. It lists every step in the process. All right. So we need this to write our code. So now let us, somebody can take a picture of this so that when old people refer back to it, you can tell them what was said. They hear you.
All right, it's sir.
Okay. So you need some time to write it.
About 2 more minutes.
All right. So we go walk one side. Go. Need some vitamin D. You know the house all day. So go walk and come. All right. Write it down yet? All right. Tell, when you finish writing, just tell me. All right. So here what I'm going to do. Each of these lines represents a line of code. So starts when the start switch is pushed and the inlet open, and ends when the limit switch is activated. So let me write the program, the line of the ladder logic, the rung for that one. So it starts when the start switch is pushed. So I'm going to put my 000.00, that's my start switch. When does it end? This is going to tell when it ends, and this is what is activated. So this is my start. When does it end? First line.
Limit switch, sir.
So the limit switch. What's the 000.02? And what is started? Which is the inlet. And it is 010.00. That is the address for the inlet. And like I said, we make it universal, so we get to latch it. So that is my first line of code based on the statement that I have. So my second line of code is start when the limit switch activated. So we're going to put our limit switch to 0.00.02. When does it end? So 10 seconds. So we need to count 10 seconds. We need a timer. We're going to label that timer number 1. And the stir is 0.10.01. And again, we're going to latch it. The third one, so the timer is like an egg timer. It's going to, when we write the program, you see that it's going to count down. And when it counts down, at the end of it, you're going to set a bit high. So we finish. So when the timer counts down, the timer that is going to start the next phase, which is the outlet valve. And that's 0.10.02. We're going to latch it. And
What the other sir?
so we're going to put in the next timer because we're going to count for 20 seconds and turn it off. So that, in essence, is our program. But we just want to talk about two things. We need two timers. So this is the program, but then we have to, so I'm going to put it over here. So we're going to start two timers. So in the program, there's a box or a function block, sorry, let me use the correct technical term. Timer number 1 and timer number 2. No. So timer number 1, timer number 2. We have to say how long timer number 1 is going to time for. Now here's the thing. Timer number 1 is going to time for 10 seconds. What we have to do is indicate to it. Remember, say we humans use decimal. Machines use hexadecimal. So this hashtag that you see inside, whenever you write in the code, you're going to push hashtag to say that it's decimal. If you don't put it in, it's going to read the value as hexadecimal. So that's the first thing. So you have to you're going to put the time in, but the first thing that you have to do is put a hashtag to say we are using decimals. If you don't put the hashtag, it's going to read it as hexadecimal. All right. So the second thing that you have to do is that this timer, the timer in the processor is configured to run measures the default of 0.1, 0.2, 0.3, 0.4. So you can time something for 10.4 seconds. So when you are doing that, you have to add an extra 0 to whatever it is that you are counting. So in other words, 100 represents 10 seconds. So you have to multiply anything that you're doing. It counts in default of 0.1. So 100 means 10 seconds. All right. So the timer number 2, you'd have to put in number sign 200 for 20 seconds. So you have label the timer number 1, number sign 100, you say 10 seconds, number sign 200 for 20 seconds. Now you have to tell the timer when you turn on. So let me deal with the first thing. You have to look back at the program. The timer number 1 is in this row. So the limit switch is what you'd use to turn on timer number 1. So you'd use the limit switch, that's 000.02 limit switch. We're coming back to this in a little while. And timer number 2 is turned on by timer number 1. The timer number 2 is going to be turned on by timer number 1. And then that will be the end of the program. This over here, so? No, because the thing, this is in the way. This up here, the clock start. We need a clamp stand that goes to the ground, and then it would be in the way. And then I have to be using my phone instead of the tablets.
So sorry, actually, 3 wrong we don't have, but it doesn't show how to punch in the data for the timer.
Yeah, but you have to put it in the program.
Okay.
All right. So this is the program that you run. Press the start button, turn on the inlet. When the level switch trigger, it turn off the inlet, but when the level switch trigger, it turn on the stir. Stir turn on until the timer says timeout. Turn on the outlet, and so forth. But from practical experience, when we run the program, there's a problem. The problem is right here. When you actually have a tank with a stirrer inside here, and let us say there's water inside here, what happens is that the water is going to agitate this, so the level switch is doing like this. Follow the marker, the level switch is going up and down because the water is being agitated. Which means that the level switch is turning off and on and off and on and off and on. So therefore, this timer here is turning off and on and off and on and off and on, and it gets confused. The timer is like most people. They confused, they don't stop. No business with you. You can't go and do whatever you do. So, although in theory the program works, and if you run it, because we're going to talk about how you run the program using, you're going to simulate the program. If you simulate it, it works fine, but when you practically wire with it, there are going to be problems. So you have to anticipate that. And you cannot know until you start running the program that there are going to be problems. So you have to have, first you have to simulate the program, and then you have to do an action. You can't just say, oh, it's working in simulation, so we have the multi-million-dollar project. And then boom, they say it's not working, and then you say, wow. You have to do another little test first to see what are the other hitches that you can have. So, most of the time, most of the hitches that you have, you need to try to solve them with the software and not with the hardware. You need to try to look and think of how you solve the problem using the software and not the hardware. Tell me why you have used the software and not the hardware. People is one, but the most important thing is, it's much cheaper, right? Much cheaper. So let me tell you what the fix is for this. The level switch is not behaving, but the reason why the stirrer don't have a problem is because we latch it. So once the stirrer turn on, it stays steadfast in that moving. So the level switch turn on the stirrer. So instead of using the level switch, we use because this is also turning on the timer. I mean turning on the stirrer. When you turn on it, so it's two things we have here. So instead of using the level switch, we use the output, the stir, to turn on the timer. Because when this turn on. But when this turn on and this turn on, the stir, once it turn on, it latch. So it will stay. So you see the beauty of latching things as well. When you turn on, if I didn't have this line in there, then I would have to find another way to fix. Well, the software turn out and fix everything that we need to fix. So this now would represent the program. Let me just turn your attention to let me share the screen. All right. Now, if you're going to CX Programmer, you are going to see page come up and it's blank. So you're going to say that you want a new program. Now, first and most important thing that persons forget. You see this that come up? Everybody see this screen? All right. The first and most important thing, you see this thing that says device type? You have to put in which PLC you are using. And if you click on this, you see a whole heap of because they have all the various brands of PLCs put out inside here. And so you have to say which one of them you are using. The log is CP18, so you have to put in that because if you don't put in that, it's not going to take the program. Sorry, it's going to look at you when you press run and you don't know what is the problem. You say, but why not run? You put in the wrong PLC. All the brands are there, you need to put in the brand that you are going to use. So put in the right brand and then it comes up. Now, to put in the program that as we have it, all right, you click on Open Contact and you drag it out. When I say drag it out, all I do is click on it and then go to where I want to put it. Now you're going to put it, click in the spot where you want to put it. It's going to ask you for the address. So the first one that we have is 000.00. And you say, okay, and it's going to ask you to tell it what is the name. So the name is the start switch. And you tell it, okay. So now, let's just make a point here. You see, this red line is very important. This red line is saying to you that your program, your ROM has a problem. It's not complete. When the ROM is all right, the red line is going to disappear. So we have the start switch. The next in the program is our normally close switch. Drop it in there, and its address is 000.002. And again, it's going to tell me, so I'm going to put level switch. Press OK. Then I'm going to put on the output. So that is 010, that 02, that 00, sorry. So that's our output. And we say that that is the index value. Now, see now the red line disappear because this is a complete program. But we need to put in the latch. So we're going to click here and put in 0, 1, 0.00. Press OK because and then it will ask us. Sorry, it asks us. And then we join it. Using the vertical bar, we join it up. So this is our no red line. This is our complete row. So we're going to do the same thing. Now, a lot of times when persons wiring up the circuit, have put in the code, they put the other one down here, and it is going to accept it. Let me make the point. You put it there and it accepts it. That is wrong. It's the same. This wrong, each of them has a unique number. So this is wrong 0. The next line in the ladder should be 1. All right. So you can't put it there. You have to put it down here in line 1. So the new contact that we have is 000.02. I'm being technically correct. Put the pointer 00.02. You find out, say you can just put 0002 and it works just as well. All right, now this is the first issue that we have. We have to put in a timer. Now I have put TIM1, but in this particular program is T1. We have to write down for timer 1. And people like me always make the mistake. So we need to say is the stir timer or whatever you want to put. So in this particular program, let me just make the point. In this particular program, it don't say TIM1, it's a T1. If you are using another, because CX programmer is not the only thing that is used to program Omron, they have another thing called Syswin. Syswin, you have to use TIM1. Just some of the little quirks that you have with this thing that you have to live with. All right, so this is 010.00. Hopefully you're gonna drop asleep. Well, it's all right, but we have to write the program. Okay. Very important. Good thing. I didn't do it deliberately. But notice here. 100, 100, and this program is telling me, say, but Bridget, you have two same input and 2 different runs. You must never have 2 same input and or 2 different runs. So there's a problem. So, yeah, but this output is the same as this output. But I should have put 0, 1. So let me.
So Chris, how you keep track of all of them addresses when you actually sit down and write on 709?
If you're writing a 700 line program, then it's not one of you going to write the 700 line program. It's going to be a team of you writing the 700 line program. And you have to make sure that each of you just keep track of it.
Okay, so
All right. So now we have the new corrected version. So we're going to continue. All right. So now putting in the latch 010.01. Wait. No, commit. Oh, we never put any. All right. Red line. So we have to correct it. So that is another wrong. We could do the third one quick. All right. So we could do the third one and then we just need to talk about the timer, the two timers. So put in this one quick. Timer 1. Put in the next timer, timer 2. So this is the outlet timer. And output is 010.0. And that is outlet. All right, so when we put outlet to 010.02, all right, so now we'll come to the next part now. All right, so there's a red line. So there's a problem. So try and see what is the problem. We could take out them two extra line here. Put them back. All right. So there was some issue there. Here. The way to type in says timer number 1.
Sir, can you direct us back to the function square, please?
What again?
The function square.
Function squared. Oh, let me go again. Up here, sir. This, look in this line, the same line with the open circuit and the closed circuit and everything like that. You have this little box here that says new PLC instruction.
Oh, okay. Thank you.
You click on that. And I'm clicking on details because we want you to see everything. You don't have to click on details when you know what to do. It's just, so the first thing is going to be TIM. Then you put in number sign 1. Right below it, there's another box. You wouldn't see it. You wouldn't see it, just, you have to know so there's another box down there. That is where you put in the number sign 100. Then when you do that now, you can press OK. And you see it come across TIM, timer number 1, and you count it for 10 seconds. So we're going to do the next one for timer number 2. So the switch. All right, so we're going to put in, sorry. Okay. Okay. And then we're going to put in there's one other thing I need to show you. So the details now. So this is the timer. And if you do that, what I just do, you're in problems. I didn't put in the number one. So here what I'm going to do. This sticker white thing get you back. I'm going to get rid of it altogether and start back over. So putting in back the instruction. The last thing I want to talk about. So TIM for the next timer. Timer number 2. By the way, it starts at timer number 0. So you can start from 0 to 6656. You can time 6,656 different events. And then we put in the number sign 200. For number sign 200. What does it say? It's a 3. All right, so this is your program. Now in CX Programmer, it will run like this, but in other PLC programs, it don't run like this. So I'm going to put in the extra instruction because I'm not teaching you how to program CX Programmer because you might, when you go through it, you might most likely will not see CX Programmer. So we're just making sure that you follow proper programming procedures with everything. So we're going to put in here another important thing for a lot of programs, end. This program don't require to put end. But like I said, this is not the only, Omron is not the only device you're going to code. And Omron machine don't only use CX program, it use other programming constructs. Same thing, but other people write programs to program Omron. And in the other programs, you have to put in an end. So that's why I put it in the end. You don't have to put it in when you're using CX Programmer.
Sir, scroll back up, please. Yeah, but that's all the parts.
So this will be the program.
So, Mr. Fraser, every time your time device or something, you have to program the timer separately. Or
Your voice start out higher, then it go low until we don't hear no. You say every time.
yeah, hear me now, sir?
Yeah.
Yeah, so every time you put a timer on a device, you have to program them separately like we do down here. Sir.
Yes. Every time you put a timer on a device, if it's not the same timer, that meaning that each of them, the devices that you have, if it's a different time, and yeah, you have to put a different time on it. No matter if it's the same time, you have to put a different time on every device. But you're allowed 6,556 or 6,656. I remember, but we don't need so much timer, so therefore it don't really matter. But the timer
for the last timer is 200 is you put number 200.
Yes, for 20 seconds.
Okay.
I remember now, if you don't put the number sign, I think 100 in hexadecimal is 64. So it will time it. It will read 100 as hexadecimal and then convert it for you to 6.4 seconds. So you have to put the number sign beside. All right. So that's what I wanted to talk about today. we continue this for an hour on Friday. But like I said, there has to be an in-person session to deal with the wiring up of the PLC.